So this next session, we're pivoting from this morning, we were talking about detection and threat hunting techniques. In the second session today, we're going to be looking at some of the techniques that are important to support a lot of this research that you all are doing, specifically looking at infrastructure needed to maintain some of this research, as well as data and methodology considerations. So first up, we have Konstantin Berlin, who's going to present on SQL-driven infrastructure for cybersecurity ML operations. So I'll pass it over to Konstantin.
Thank you. Oops. So actually, maybe to start with, this is an image that I just took my title and I put it in DALL-E 3. And that's what it came out. But you can see on top, it's attempt to integrate SQL into the image, which didn't quite work out, as you can tell. So, who am I, and why should you listen to me, and why should you care? So, I formerly was the head of AI at Sophos. So I led AI research at a cybersecurity company, a fairly decently sized one. I worked on these problems for a lot of years. And when I sync up with my team, and I ask them, like, what have you done this week? The typical response would be like, well, I wanted to do a lot, but I tried to collect my data set. I ran out of memory. Then I started engineering a lot of infrastructure, and I'm basically in the same spot I was like last week ago, right? I'm sure everyone's familiar with this problem. So I think bad infrastructure is actually probably the main problem for most AI teams in general. Like, this is the number one thing that destroys efficiency in the team and makes the work that they produce much worse, because they have to start making compromises in terms of the data that they use. Now, oops, forgot to start my timer. But if you have good infrastructure, then you can do a lot of good work. And actually, there are going to be 2 talks on this, I think tomorrow, and both of them probably would not be happening if it wasn't for the infrastructure that it was built on. So if you're successful with your infrastructure, I think you will succeed with your research. And the reverse is also true. And again, the views are my own, nothing to do with Sophos. Okay? So the first thing I think that you need to understand about cybersecurity is that basically it's an adversarial environment, right? So it's constantly changing. And for that, there is this concept of the OODA loop, right? Which is sort of you deploy something, you observe, you take the feedback back into your sort of decision making, and then you update your detection mechanisms and so on, right? This concept was developed in the military, and I think it's an apt analogy because cybersecurity, basically, you're at war, right? And don't take it lightly. These people, they're trying to destroy your company. They're trying to steal from your company, right? And they're going to use any means necessary to do so. So you're basically at war. And if you know something about recently that we learned about war, that war is a test of logistics, right? And in this case, your logistics is your infrastructure. So you're at war, and the infrastructure is probably the most important thing that's going to be driving your success or failure, right? Your infrastructure sort of drives how fast you can iterate between new detections, deploying new detections, right? How fast you can adapt. Your infrastructure drives how much information you can take into your decision making, right? Because the more complicated information you can take in, the better the decision making that you're going to be making. And the infrastructure can also prevent you from succeeding, right? Because it typically spreads all these resources around, and you're sort of stuck, fighting the bureaucracy of your company, or just, the expense of moving the data around, getting permissions. Even if everyone has good intentions, you're still going to be going very slow. And this becomes even more important as a lot of cybersecurity moves away from sort of what I would say like protection, which is like, here's a model on the endpoint, it makes its own individual decision, to the decision making being centralized in these XDR, MDR components in the cloud, right? Basically where you collect all the data, and then from that collection, you can make significantly more complicated decisions because you see events over time, you see, information from your firewalls, from your endpoints, everything can be combined together, right? But again, this significantly increases the complexity of your infrastructure because you're no longer doing decision-making sort of on the endpoint itself, right? Now, I made a meme. I'm not very good with memes. Hopefully it's funny. But basically, like my experience, and maybe your infrastructure, is much better, and you're much better off. But typically, what I see in terms of infrastructure is cybersecurity infrastructure. Is sort of you take in the data, you decorate that data. So there's this concept of decorating the data. For example, you go and you look something up in VirusTotal, and you're like, oh, have I seen this file before? Yes, no. They pull in that data. You propagate that data now to the detection part. In the detections, you have your ML, you have your rules, everything like looks at all the data, the decorations, and it makes its decision. And then sometimes you can make a decision there. Sometimes you push some of that data down in a warehouse so the analyst can review it later, and so on. And then from that warehouse, and meanwhile, what you're doing is like sort of collecting little bits and pieces of telemetry from all these decorations, detections, what people typically call data hydration, though I don't think a lot of water gets in, personally, right? And then the little drip, gets to data science, and then the data scientist opens up a Jupyter notebook with like 16 gigs of RAM, and then they try to do ML, right? So this is the main problem. Now, there's a lot of problems with this thing, right? And I can rant about it probably for about hours. Like, for example, decorations, you have to build individual databases for these decorations. There's very limited information in it, much less, let's say, than you have in your warehouse. There's complicated relationships between detection components, meaning if you ever try to change your pipeline, everything falls over. Like if you try to change a detector or you change a decoration, your detectors break. It's really, really bad, right? And the question is why do seemingly, smart people make these kind of decisions? And I think it's because this is sort of like what I would term, this is like an infrastructure created for peacetime, right? This is peace. This is like you're serving ads. I don't know. You are, producing unicorns and lollipops and bunnies, right? But this is not the right thing, right? Because you are technically at war, right? So you need a wartime infrastructure, and the problem with this infrastructure is this is just my perception of how it is. It's that it's imperative, right? What you're doing is you're talking about the how, right? I'm going to put this data here. I'm going to put this data here. I'm going to isolate this component. I'm going to try to drive down the cost. And when you do that, you create a very inflexible infrastructure, which eventually falls over, or you're just stuck not being able to deploy anything for years, right? Which is, in a wartime infrastructure, is really bad. So in the meantime, right, there is a thing that I think a lot of data scientists love, which is SQL. And SQL, if you think about it, is basically a declarative environment, right? You're not telling the database how the table will be created. You're just telling the database that a table needs to be created with these properties, right? It takes data from here, take data from here, and make it happen. Now, why traditionally this hasn't been like really used because that much, I would say, in these type of pipelines, and that's because this automatic component of these databases, it wasn't very good. Like you try to use a database, and then you end up going from declarative to imperative because you're constantly trying to hack this system to make it work for your data sizes. But what happened recently is sort of, I wouldn't say it's a revolution, but it's like a change of mentality. What you have is cloud native declarative SQL databases. Snowflake, the one I'm most familiar with, the one I use. And the change is that it's centered around the cloud. So it thinks differently. Like traditional databases, sort of like you start splitting the data around this, this node has access to this data, this node has access to this data, you start playing data tricks. Here, what's happening is that the data goes to the data lake. Like the data lake is the cheapest thing that you can possibly do. It's the lowest cost environment for storing data. And what it does, it separates the compute from the data. So you no longer have any limitations, right? If you need to scale up instantly, you can scale up instantly because it's the cloud, right? The database doesn't have to be sort of resharded around as you increase sort of its compute power. And at the same time, because everything is separated, you can sort of maintain multiple workflows at the same time without any additional cost sort of with the system. Because all the data goes to one place, you no longer have these data silos. Now, there were a few problems with this approach. One is like, SQL database is really not good at supporting semi-structured data. Semi-structured data is everywhere in cybersecurity. This has been changing dramatically over the past few years. There is really good semi-structured support in this database. The other part is sometimes you have Python, whatever, pipelines also, you need to execute Python code, right? And that can also be now integrated into a database, right? So the infrastructure that I build and I propose in general as sort of a wartime infrastructure for doing ML and cybersecurity is one centered around the warehouse, right? So it's like there are no pipelines, explicit pipelines. All the pipelines are logical, right? It's like this SQL, this SQL, this SQL, this SQL statement. You can orchestrate it centrally, and all the data is in the same place. It's in the warehouse. How the warehouse does that, that's sort of, that's where the warehouse team, the team that builds the warehouse, right? That's the problem they solve, right? Should they be caching this data? Should we be storing this data in S3 or not? How do we handle streaming? That's their problem, right? Your problem is to declare what you want to do and then do it and then execute on that. And to me, this is like as simple as it gets, right? Everything is driven by SQL, including Python, which is driven by SQL. The team is self-enabled because they can declare their own SQL functions. Or if you have more complicated infrastructure, it can be directly connected through the warehouse. So the whole pipeline is just a bunch of SQL statements. And then there is sort of this, so this is, I would say, declarative. And then the other little trick I would say that's very useful is making everything is immutable, right? So typically when you're building your pipelines, you have component X. You need to update component X. You take down component X version 1, and you put in component X version 2. When you do that, there is a chance that you're going to break some pipeline that uses component X because they rely on component X version 1, and you just install X2. So what you do is you blast communication to your whole company. You're like, I want to take down component X and replace it with updated component X. Am I going to break anyone's workflows here? And then they say yes. And then you start saying, well, can you update your pipeline to take component X version 2? And they say yes, in 6 months, I think we have some time. And the whole thing sort of like, and then everything gets stuck, right? So now you can deploy your component X, but you needed your component X because you wanted to try out a new component Y. So nothing gets done. So if you mix sort of this warehouse with an idea, I guess, that you can take, if you ever done parallel programming, right? If you're doing parallel programming, then the easiest way not to get yourself in trouble is to make all objects immutable, right? They cannot change. Because if they cannot change, there are certain guarantees that no matter what the other threads are doing, they're not going to destroy what you're doing because it's immutable. So instead of replacing objects, you add new objects to this system, right? Which is why I call it immutable. So you have these containers. If you're running container services, right, you never take the container, you say container 2. And then you update the pipeline to version 2. The pipeline version 1 still runs. Everything is there. Because this is not as scalable, eventually, if nobody uses version 1, it sort of scales down, the costs go away. And what I found is that this is, super simple. I mean, just to give you an example how this thing works, right? If you can see the example on the bottom, right? This is typically what people want to do, right? They have a new model. They want to score it against all the data they have seen in the past year, for example, and see how the model does. So simply, right, you say, okay, I'm going to extract the features, the whole URL feature extractor. It could be a container, it could be UDF written in Python or what have you. You have your URL model. It's a PyTorch model. Again, part of UDF, part of the container, who knows? And basically a task that probably would have required you months of infrastructure work in order to be able to put it, like if you're a data scientist and you create a new model and now you have this model and you need to score it against billion objects, right? You're self-enabled. within a few minutes, you can score actually a billion items, which is not possible in the previous, like for example, pipeline. This is not even remotely possible because to actually test your model, you have to put it back up there and see how it sort of reacts with the whole pipeline, because that part is separate from what the data science observes. And that's sort of the beauty of a unified infrastructure. Now, how does this work in practice, right? So I'll just give you an example of the URL pipeline that we had. So at Sophos, we process a lot of URLs. We need to build detectors around URLs, whether it's categorization, which is what the talk one of the talks is going to be about, or just detecting if a URL is bad or good. Now, when you do that, when you try to build a pipeline to do that, the first thing you run into is that you typically want to normalize your URLs because they come from different sources and they have sort of like a little bit of artifacts that differentiate between sources. Like an example on the bottom, right? Same URL, just different ways of encoding it. So you build your normalization function, and then you push all the data through, and then you start trying to build a model, and maybe you succeed partially, maybe not. Then you develop a model, you put it back up, and then you have to re-ingest all your data again in order to be able to score that data with the model. Now, like a typical problem here is that like you made a mistake with the normalization function, right? You can never get the normalization function correctly. So what happens then? Well, then you have to rerun your entire pipeline from scratch. Like it's stop the world, recompute the whole world type of an event. So you bankrupt yourself because you have billions and billions of URLs, and potentially this pipeline falls over because it scales, but it doesn't scale from you had 1x traffic flow and now you have 100,000 traffic flow that you're trying to do, and typically these pipelines fail over because of that. So you get to this point and you're like, the normalization function, it's wrong, but there is nothing I can do about it, and you sort of give up and you try to build an ML model, and maybe it works and maybe it doesn't work, but your labeling is definitely not as good as it could have been. Now, and it's super complicated. Now, if you move to this sort of SQL-oriented infrastructure with using new type of technologies, right? These data warehouses. The first thing is you can get rid of a lot of these decorations and normalizations of the data, right? If the data is semi-structured, doesn't matter. You get rid of all these components, and you're going to move them post-ingestion into the database. And then because all the data is in the database, and all the labeling functions are inside the database, it's easy to recompute multiple labeling functions, try things out, iterate, right? The most important thing is that you want to iterate as fast as possible. And this ended up being sort of the new ingestion pipeline, basically where we take the raw telemetry, we don't do anything to it, we just put it in the database. In the database is where we have all these Python functions that sort of define how you normalize the function, how you label functions, how you label URLs. All that is being pushed in that. It has access. In the database, you have access to every model you ever built before. It's just floating there in the cloud as a container. So you can check how all the new data works against an old model. You can put up your new model immediately, and you can check how data works. You can build your detection actually pipeline, right? So previously you have your detection pipeline and then you have your data scientist workflow. Here you have one workflow. Everyone has access to the same infrastructure. You don't have two infrastructures. You have one infrastructure. And because the infrastructure supports production level data, you know that it will also support machine learning research capabilities, right? Because all the components do scale because it's the same pipeline. So what happened as a result is it's hard to define how much improvement this model this type of approach created, because it's like you start with 0 and now you're doing something in 3 months, right? So it's like if you're multiplying by 0, it's like infinite sort of improvement. Right. And that's basically what happened. You have infinite improvement because there's simply so many projects that were not possible. Like, I mean, maybe possible with a few years of investment, but something nobody can undertake because they would need to build their own infrastructure, and machine learning people are not necessarily people to build infrastructure. And the infrastructure people, they don't know, what you want, and they're also busy. So nothing ever gets done. It significantly, it like enabled the data scientists to data wrangle huge amounts of data. So we're talking about a person who knows nothing about big data. They can process 1 billion items. They can featureize 1 billion items within a few minutes, right? So it just becomes about how much money you want to spend versus how much time things take. And because all the components that you have are inside the warehouse, right? So production pipelines, but also new pipelines, you can immediately test a new pipeline because that's just creating another virtual sort of declarative walk, a sequence of SQL statements. And you have access to all the components because the rule is you put up all the components, they're immutable, you can never take them down. So if anyone ever wants to test against something old, it's there, and it's guaranteed never to break. And finally, the other part is because all the raw data is also in the database, even if you make some sort of processing mistake or you realize you need this piece of data but not this one, the data scientists themselves, without going anywhere, they can go back to the original data, the semi-structured data that's dirty, messy, and they realize they made a mistake. They just reprocess it themselves. So, you're empowering your own team to solve their own problems. And I think that's sort of the critical component in this system, because again, sometimes you worry about like how you're going to do it, but here you just worry about what you want to do. And again, it's a test of logistics. And sometimes maybe it's more expensive to do something this way, but you get more things done and you get, better outcomes. And the big thing to realize is that you're not even if your SQL statements are expensive, you're not helpless. It's a database, right? There are ways to improve things. You deploy first, you build indexes later, right? You realize, okay, this table is slow, I'm going to build an index. But the building of the index in the table, that's not something that's, that breaks anyone's workflow. That's something under the hood. So you tune the warehouse to do what you want to do versus creating the, pipeline specific infrastructure. That's sort of, I'll stop here basically. This image is basically, my kid saw me generate the first image sort of in these slides, and he got really excited and he wanted to see what happens if you type electric castle in space that has 100 dogs in it. And this is what you get.
Thank you, Konstantin. All right, we have time for just maybe one or two quick questions.
So immutable objects is like really nice from that, like, let's go back and make sure things are cool standpoint. How does that, did you have any friction with the concept of like, oops, there's a vuln in WebP with a score of 10 that is going to pwn us because we were crawling untrusted images, and like, we cannot keep this immutable thing around anymore because we have to rebuild on it?
So, sorry, well, what is this question?
So if you have immutable, you're like, I had this image recognition pipeline 2 years ago from Pillow 9,
right,
which has a catastrophic WebP vuln in it. And now we need to update. Like, we cannot keep that immutable object around. Did you have any friction with like, we wanted that to be immutable, but we can't because it's a catastrophe?
No. I mean, like, again, security is like, it's, having the right security policy, I would say, is like, it's good and you should have one. But this is more about like conceptual. Yeah, I mean, you can do whatever. You can isolate it, take it down, whatever. I mean, whether the container should be properly isolated, everything should be correct. But I think you need to be careful about updating components instead of just creating new ones, because any change that you make is going to potentially impact your pipeline. And then, machine learning is very sensitive to that. So yeah, I think you should take it off production lines, but it should be there in case someone wants to see what happens.
All right, we'll do one more quick one from online. Raphael is asking, how do you manage the SQL queries? What about version control, unit tests, CI/CD?
Yeah, I mean, so it's not like again the end all be all. Like this is a, yeah, you need all that, right? You still need all that. SQL statements can be complicated, hard to parse. You have your own problems there, but you definitely move much quicker. And hopefully there'll be solutions forthcoming to sort of understanding SQL statements and modifying them. All I can say is like make sure you write good SQL statements for now. Yeah.
Okay, great. Thank you so much, Konstantin.